This is the lecture for lesson 6. This section is all about rational expressions. So we are going to be multiplying, dividing, simplifying, and adding some fractions, which are also called rational expressions. We are going to be simplifying fractions. And in order to simplify these, we're going to have to do some of the factoring we just did in the last section. And then we can cancel out factors that are the same. These problems are going to take a little bit of time. So this section will be a little long, even though there's not a whole ton of examples. Let's look at the first one. X squared plus 4x is over x cubed plus 2x squared minus 8x. So the first thing I'm going to do is I see I have two terms on top, and they are not perfect squares, so I'm going to start with a GCF. I can take out an x from each of these pieces. That's going to leave me with x plus 4. On the bottom, I also see that there is an x in common with all of these pieces, so I'm going to take that out. That will leave me with x squared plus 2x minus 8. So what I see immediately is these x's are going to cancel out. So I'm going to get rid of those x's. So what I have on top is still x plus 4. But now I have a trinomial on bottom, and I need to figure out, can I factor that trinomial? The rule is the two numbers need to add to the middle and multiply to the end. So are there two numbers that multiply to -8 that also add to 2? Well, working with 8, 8 and 1, or 2 and 4. Working with 2 and 4, if I do 4 minus 2, I get 2. And 4 times -2 is -8. So the bottom can factor into x plus 4, x minus 2. And you'll see then that the x plus 4 on top will cancel with the x plus 4 on bottom. And that means that this first one simplifies to just 1 over x minus 2. And this is the process we're going to follow for all of these problems. On top for B, we have y squared minus 4y plus 4. And on bottom, we have y squared minus 4. Looking at the top is a trinomial, so I'm going to look for two numbers that can multiply to 4 and add to -4. So what times what equals 4? Those same two numbers add to -4. That would be -2 and -2. So y minus 2, y minus 2. -2 plus -2 is -4. -2 times -2 is +4. So that one is there. On bottom, y squared minus 4. That is a difference of squares. So that is that special one. Y squared is y times y. 4 is 2 times 2. One gets a plus, one gets a minus. And then you can cancel out one of the y minus 2's on top with the y minus 2 on bottom for a final answer of y minus 2 over y plus 2. C, a squared minus 5a minus 24 over a minus 8. So I can't do anything with the bottom, so I'm just going to leave that a minus 8 there. And on top, we want to multiply to -24, add to -5. So thinking about 24, 24 and 1 can't get me to 5. 12 and 2 can't get me to 5. 4 and 6 can't get me to 5. 8 and 3. Let's see, -8 and +3. -8 plus 3 is -5. -8 times 3 is -24. All right, so that's a minus 8 and a plus 3. That works out nicely again because we have an a minus 8 on top and a minus 8 on bottom, so those are going to cancel out. This simplifies to just a plus 3. Next one, 2p squared plus 8p minus 10 all over 2p squared minus 4p plus 2. So before I do anything here, I want to make the problem easier, and I'm going to make take out the 2 on top, take out a 2 on bottom, because all of the numbers are even. So if I take out a 2, I'm left with p squared plus 4p minus 5. If I take out a 2 on bottom, I've got p squared minus 2p plus 1. So I'm just factoring out a 2. And now I have 2 trinomials. So what plus what equals 4? Those same 2 numbers multiply to make negative 5. Well, there's only one way to make 5 when you multiply 5 and 1. So I have to figure out that's going to be 5 minus 1 to make 4. And 5 times negative 1 is negative 5. So on top, I have a 2. I have a p plus 5 and a p minus 1. And then on bottom, we got to multiply to 1, add to negative 2. So add to negative 2, multiply to 1. Well, the only way to multiply to 1 is 1 and 1. But in order to make those negative 2, they'll be both negative 1s. Negative 1 plus negative 1 is negative 2. Negative 1 times negative 1 is 1. So this is going to be p minus 1 and p minus 1. I can't lose the 2 that was out front. So the 2's will cancel, and I'll have a p minus 1 cancel, left with p plus 5 over p minus 1. Next up is multiplying 2 rationals together. Basically just means we have more factoring involved that we're going to do and then canceling out again. So now I have a fraction times a fraction. So I have 4 pieces I'm going to have to factor, and then I can cancel anything on top with its matching piece on bottom. So working first with that y squared minus y minus 12. I want to find 2 numbers that multiply to negative 12 that add to negative 1. So that pair is going to be negative 4 and positive 3. Negative 4 plus 3 is negative 1. Negative 4 times 3 is negative 12. On the bottom of this one, I have 7y minus 28. 2 terms. None of them are perfect squares or cubes, so I'm just going to have a GCF. Out of 7y and 28, I can take out a 7. And that will leave y minus 28 divided by 7 is 4. I'm going to carry the multiplication sign, and I'm going to now work on the second part over here. So 7y minus 7, again, 2 terms, no perfect squares or cubes, but they do have a 7 in common, so I'm going to pull that 7 out, leaving me with y minus 1. And then on bottom, I have a trinomial. So my goal is to multiply to 6 and add to 5. So if I want to multiply to 6, 3 and 2. 3 plus 2 is 5. 3 times 2 is positive 6. All right. Next, we can cancel something on top with a piece on bottom. We can treat this as a full whole fraction here. So 7 can cancel with 7. Y minus 4 can cancel with y minus 4. Y plus 3 can cancel with y plus 3. So all that's left is y minus 1 over y plus 2. Working with b. R squared plus 6r minus 27 is a trinomial. We are looking for the 2 numbers that are going to multiply to negative 27 add to 6. So if I multiply to a negative, I got to have one positive and one negative. And what would that be? 9 and 3. 9 minus 3 is 6. 9 times negative 3 is negative 27. On bottom here, we have r squared minus 3r. So again, we have a GCF of just r. And I'm left with r minus 3 inside. The second fraction here, r squared plus 5r, has a common factor of r that I'm going to take out, leaving me with r plus 5. How do I know? Because r times r is r squared. R times 5 is 5r. You can always multiply it back out to make sure you did it correctly. And then this one here is a trinomial. So we got to find our numbers that multiply to negative 12. If it's a negative, one's got to be negative, one's got to be positive, and adds to negative 4. So 6 and 2, 3 and 4. 6 and 2 to get me to 4. But I want negative 4. So negative 6 and positive 2. Yes. Okay, looking at what we can cancel out. An r is on top and bottom, and an r minus 3 is on top and bottom. So what I have now is r plus 9 times r plus 5 over r minus 6 times r plus 2. Now, depending on the homework system, if it wants you to leave it like this, that's fine. It also may want you to go one step further and multiply this back out. So knowing the rule that when we factor, it's these two numbers make the sum and these two numbers make the product, we could use that to go this way. R squared plus 9 plus 5 is 14r, and then multiply them. 9 times 5 is 45. And then I can do the same thing on the bottom. So r squared, their sum, negative 6 plus 2 is negative 4r, and negative 6 times 2 is negative 12. So it is a little shortcut that you can do if you're just working with ones like these. We have two more multiplication problems here. X squared plus 4x minus 32 is the first piece we're going to factor. So trinomial, we want to find two numbers that multiply to negative 32. So one's going to be positive, one's going to be negative, and that they add to 4. I think that's going to be 8 and 4. 8 minus 4 is 4. 8 times negative 4 is negative 32. All right, bottom of that fraction, x squared plus 13x plus 40. Again, a trinomial, so we're looking for what multiplies to 40 that also adds to 13. So 4 and 10, that would make 14, so that doesn't work. We have 22, no, 8 and 5. 8 times 5 is 40, and 8 plus 5 is 13. Got it. On top of the second fraction is x squared plus x minus 2. So again, we need to factor this one. We want to multiply to make negative 2, add to make 1. So one's positive, one's negative. And the only way to multiply to 2 is 2 times 1. So we want to end up with 1 though. So 2 minus 1 is positive 1. And then on bottom, we have x squared plus 2x. Two terms here. That is just a GCF. So take out x, left with x plus 2. Seeing what we can cross out, I have an x plus 8 on top and bottom, and I have an x plus 2 on top and bottom. So I now have x minus 4 times x minus 1 over x plus 5 times x. So what I'm going to do is I'm going to multiply those back out. The bottom is a little bit easier. It's just the distributing. X times x is x squared. X times 5 is 5x. On top, we're going to have x squared. If I add these two together, -4 plus -1 is -5x. And then -4 times -1 is +4. And that would be the answer to C. Next is problem D. On top of the first fraction is a squared minus b squared. We have two perfect squares with a subtraction between them. So that turns into a plus b and a minus b. On bottom of this first fraction is a squared minus 2ab minus b squared. And this is the perfect square trinomial. I believe it's actually the formula. So it's going to be a minus b times a minus b. You can look back at those formulas from our factoring section. On top of the second fraction is a minus b. Nothing I can do with that. And on bottom of that second fraction is a squared plus a. I see a common factor of a that I'm going to take out, leaving a plus 1. I have an a minus b with an a minus b, a minus b with an a minus b. I have a plus b on top, and then a times a plus 1, or a squared plus a on bottom. And that is for multiplication problems. Next is division of fractions. And the rule here that it says is to remember to rewrite division of fractions as the first fraction multiplied by the reciprocal of the second fraction. When you see this division problem here, this first fraction is divided by the second fraction. What it's telling us to do is to rewrite that as the first fraction times, and then flip the second fraction over. Okay. We are then going to do the same process we were doing with factoring, reducing, canceling out what's the same, and ending up with our final answer. Now, some of these, though, you will see have a coefficient, so they're not as fast of problems to complete. So I'm going to do the easier ones first here, the denominator of this first one. I believe we did one with those numbers. Let's see. We want to multiply to -2. So the only way to do that is 2 and 1. We want to end up with -1 when we add them. So -2 plus 1 will be that pair. Working with this guy up here, we want to multiply to -8 and add to 2. So that will be 4 and 2. I want to have +2 in the end. So +4 and -2 will give me that pair. And then I need to take these to the side. So remember, we had to take the first times the last to get -12. So our multiply is -12. Our sum is -1. So the two numbers, and I ran out of space here, that multiply to -12 that also add to -1, -4 and 3, -4 and 3. What I need to do then was rewrite this one on the side. So 3y squared, and rewrite it with the two terms, -4y plus 3y minus 4. And then we factored our GCFs out. In this first pair, I can take out a y, leaves me with 3y, minus 4. And that's exactly what's over here, 3y minus 4. There's nothing in common. What I'm going to do is I'm going to put a little placeholder of a 1. So if nothing's in common, the GCF is 1. The reason I do that is so that I can make sure I have my second piece in my factor when I write my answer, 3y minus 4 and y plus 1. I need to do the same thing with this 2y squared plus 3y minus 5. So if I multiply 2 and negative 5, I get negative 10. And then I need to add to 3. So 5 minus 2 is 3. 5 times negative 2 is negative 10. So if I rewrite this guy, 2y squared plus 5y minus 2y minus 5. I can take a y out of the first pair. That leaves 2y plus 5, and we want 2y plus 5 over here. Right now I have the opposites, negative 2y and negative 5y, so I'm going to take out a negative 1. So we'll have that 2y plus 5 and a y minus 1. And now I'm at the point where I can cancel out anything in common. So y plus 1s are gone. Y minus 2s are gone. And that is all we can get rid of on this one. So I currently have 3y minus 4 times y plus 4 all over 2y plus 5 times y minus 1. And again, if you wanted to distribute that back out, you can. I will give you that answer here just so you can see it. 3y squared plus 8y minus 16 over 2y squared plus 3y minus 5. You can see that when we don't have a coefficient of 1, there's definitely a lot more work involved. And division problems take a little bit longer just because I have to rewrite them as multiplication first. Let's look now at B. I hope I have enough room here. Remember that we're going to change this into multiply by, and I'm going to rewrite this. Minus t minus 42. So I'm just going to rewrite that as now times this one here so that I'm ready to go. I'm going to do this bottom one first here, t squared plus 4t plus 3. Two numbers that multiply to 3, that add to 4. There's only one way to multiply by 3. That's 3 and 1. And 3 plus 1 makes 4. I'm going to do the other easy one here, which is on the denominator. T squared minus t minus 42. To multiply to make 42 is 7 and 6. And then I want to end up with negative 1. So t minus 7, t plus 6. And then let's see what we can do on the tops here. 2t squared plus 2t minus 12. Oh, I can take out a 2. If I take out a 2, that's t squared plus t minus 12. Oh, and then I can just use my regular factoring here. So 2 comes out. And then I'm going to multiply to negative 12, add to 1. That's the opposite of this one. Positive 4 and negative 3. And I think I can factor a 2 out of this one as well. I take the 2 out first. That's not going to make it a whole lot easier, does it? Well, let's see. If we take out the 2, that leaves 2t squared plus 11t minus 6. Now I have to figure out my two numbers that multiply to negative 12. The same two numbers add to 11. So 12 minus 1 is 11. 12 times negative 1 is negative 12. So let's see if I do this here. So 2t squared plus 12t minus 1t minus 6. There's a 2 there. Let's work here. I can take out 2t from the first pair. Leaves me with t plus 6. I want t plus 6 on this side, but right now I have the wrong sign, so I'm going to take out a negative 1. All right, we have a 2 that factored out. We then have a t plus 6, and the leftover is 2t minus 1. So I took this piece down here to factor, kind of out of the way. Now let's see what we can cancel out. I have a t plus 6 that cancels out. Let's see. Doesn't look like I have a whole lot canceling out of this one. I made one small error here. Let's correct this back here. When I factored out the 2, this should say minus 6. So my pair here should be 3 and negative 2. 3 times negative 2 is negative 6, and 3 minus 2 is 1. And then these t plus 3's cancel out. I apologize for that mistake. Let's see what we have left now. 2 times 2, 4. A t minus 2. A 2t minus 1. On bottom, we have a t plus 1 and a t minus 7. If we were to multiply these out, let's see, t times 2t, 2t squared, t times negative 1, negative 1t, negative 2 times 2t, negative 4t, negative 2 times negative 1 is positive 2. Bottom, it's going to be t squared. If I add those two numbers together, negative 6t, multiply them together, negative 7. And I could do a little more on the top here. 8t squared, if I multiply that in and combine these, that's negative 5t times 4, negative 20t, and then plus 8, all over t squared minus 6t minus 7. All right, these problems have lots and lots and lots of places that you can make a mistake. And I easily made one here. So please be very careful as you are working through all of these problems. We have 2 more that we can do here with division. X squared plus 2x minus 3 over 2x squared minus 7x plus 5. And I'm going to change this to multiply by 2x squared minus 4x minus 16 over x squared plus 9x plus 18. Working with the top piece, x squared plus 2x minus 3. So I want to multiply to negative 3, add to 2. So one has to be positive, one has to be negative. The only way to multiply to get 3 is 3 and 1, and 3 minus 1 is positive 2. I will come back to the bottom one. One's going to take a little bit. On top here, 2x squared minus 4x minus 16. I can take out a 2. Leave me with x squared minus 2x minus 8. And let's see if we can factor that guy. So leave the 2. X and x. We've multiplied a negative 8, add to negative 2. So it's got to be a positive and a negative. 4 and 2, we want to end up with negative though. So negative 4 and positive 2 make negative 2. Multiply them makes negative 8. Bottom one, x squared, we want to multiply to make 18 and add to make 9. That would be 6 and 3. 6 times 3 is 18, and 6 plus 3 is 9. This one here with the 2 in front, we are going to have to do the long way. So 2 times 5 gives me 10. So 2 numbers multiply to 10, and the same 2 numbers add to negative 7. I think it's just 2 and 5, but we have to make them negatives. So we have 2x squared minus 2x minus 5x plus 5. Working with this first piece, I can take out the 2x. If I take out 2x, I'm going to be left with an x, and I took out everything here. Negative 2 divided by 2, though, is a negative 1, so you need to leave a placeholder of negative 1. Over here, we want to get x minus 1. Over here, I took out a negative 5. That makes this x minus 1 and 2x minus 5. We can cancel out our x minus 1s. We can cancel out our x plus 3s. So on top, that piece, which was our original numerator there, is still 2x squared minus 4x minus 16. This piece is what was back here. None of it canceled, so I just rewrote it. And then on bottom, we've got 2x minus 5 times x plus 6, which if I want to multiply that out, let's see, 2x squared, put it over here, so 2x squared plus 12x, then minus 5x, and then minus 30, just doing FOIL, 2x times x, 2x times 6, negative 5 times x, negative 5 times 6. Those middle ones are going to combine. So we had 2x squared minus 4x minus 16 all over 2x squared. Those combine to make 7x minus 30. And that is the final answer for that one. So I will rewrite D in its multiplication form down here. 5h squared plus 2h minus 3 over 5h squared minus 33h plus 18 times 3h squared minus 2h minus 8 all over h squared minus 6h plus 8. We have 3 of the long ones that we have to do. So number 1 is this one here. I'm going to pull it down. 5 times negative 3 is negative 15. So 2 numbers multiply to make negative 15, add to make 2. So 5 minus 3. So 5h squared plus 5h minus 3h minus 3. Remember, we're using the middle, these two to rewrite the middle. So I can take out 5h, leaving me with h plus 1. If I want h plus 1 over here, I pulled out a negative 3. So that means that top piece is h plus 1 and 5h minus 3. Okay, I'm going to take number 2. We have 5 times 18. And that is, let's see, 5 times 18, 90. So we want to multiply to 90, add to negative 33. So if we do 30 and 3, but make them both negative, that should work. So 5h squared minus 30h minus 3h plus 18. 5h squared and 30h, I can divide by 5h. It's going to leave me with h minus 6. So over here I want h minus 6. I had negative 3h, and now I have h, so I took out the negative 3. So that means on bottom, I have an h minus 6 and a 5h minus 3. All right, third one I'm going to do in blue here. So 3 times negative 8 is negative 24. Adds to negative 2. So I think that's 6 and 4. And I want to end up with negative 2, so negative 6. So let's see, 3h squared minus 6h plus 4h minus 8. And take out of 3h squared and 6h is 3h. It's going to leave h minus 2. You can always double check 3h times h, 3h squared. 3h times negative 2 is negative 6h. Here we want to have left h minus 2. So I took out the 4 because 4 times h is 4h. 4 times negative 2 is negative 8. So that gives me an h minus 2 and a 3h plus 4. And the last one here is a simple trinomial. Multiplies to 8, adds to negative 6. I think that's going to be negative 2 and negative 4. All right, let's see what we can cancel. H minus 2s are gone. 5h minus 3s are gone. So I have h plus 1, 3h plus 4 over h minus 6 times h minus 4. Multiplying back out, 3h squared plus 4h plus 3h plus 4. I'm going to simplify that. That is, so I'm not going to put the fraction bar there. 3h squared plus 7h plus 4 all over, because the bottom's easier here, h squared. Add them together, negative 10h, multiply them together, positive 24. Again, I know that these are going to be long. They get a little confusing. So if you have questions on these, on your homework, please ask them in class. We have one more type that we're going to do here, which is adding fractions. As I just mentioned, the last thing we're going to do is add and subtract rational expressions. And to do that, we need to have a common denominator. When we add fractions, we need to have a common denominator, or what I like to call a common label. One way we can think about this is if I have 1/4, the way I read that is 1/4. If I want to add 1 over 2 plus 1, that's called 1/2. These labels are different. And when they are different, they cannot be just added together. So what we have to do is we have to make them match. And the way we do that is by getting a common denominator. So for this example here, I can turn 2 into 4 by multiplying top and bottom by 2. So this now becomes 1/4 plus 2/4, because 1 times 2 is 2. 2 times 2 is 4, and 2 out of 4 is exactly half. So now I have 1/4 plus 2/4 is going to make 3/4, or 3 over 4. Once you get your common denominator, the denominator or label stays the same, and we just add across the numerator. Looking at our first example, we have 2 over 2x plus x over 4y. What I need to do is I need to figure out what that common denominator is going to be. The work number, then variables. So the largest number I have here is 4, And I know that I can turn 2 into 4 by multiplying by 2. So I know I need a 4 in the denominator. There's also an x and a y. So I need to get 4xy in each of these denominators. Looking at that, well, how do I do that? Well, I need to multiply 2x by 2y to make that into 4xy. And if I do that to the bottom, I must do that to the top as well. So 2y times 2 is 4y. Working with the second part, I have 4y, but in the bottom I need to have 4xy. So I need to add an x to the bottom, which means I need to put an x on top. When I do that, I'm multiplying, so x times x is x squared. Now I am at the point where my denominator or label is the same, and I can just add across the numerator, creating a single fraction with denominator 4xy. So it is 4y plus x squared over 4xy. Next one. 4 over x squared minus 3x plus 2 minus the fraction 2 over x minus 2. Let's see if we can factor this first one to figure out what we may be working with here. Multiplies to 2, adds to negative 3. That would be negative 2 and negative 1. So x minus 2, x minus 1. So it looks like that's going to be our common denominator. X minus 2, x minus 1. This one has the x minus 2. It needs the x minus 1 piece. So this first fraction isn't going to change. It has the x minus 2 piece, but it also has an x minus 1 piece. Now this next one, it currently has the x minus 2 piece, but it needs the x minus 1 piece. So if I put it in the denominator, I also have to put it in the numerator. Now, one thing I'm also going to do here is I do not like writing the minus sign here, so I'm going to change this to plus, and I'm going to put the minus sign right next to the 2 just so I don't lose it. I'm working with that second one because this first one's clearly not changing. Negative 2 times x is negative 2x, and negative 2 times negative 1 is positive 2, all over x minus 2, x minus 1. I'm now at the point where I have like denominators and I can add across my numerator. So I'm going to write this as a single fraction, adding anything I can across the top. So 4 plus, I can add that to 6, and then there's that negative 2x. And now that is a single fraction. We have 2 more problems. 8 over x minus 2 plus 4 over y plus 1. Looking at these, there's absolutely nothing in common between the two denominators, so it's going to be x minus 2, y plus 1 in the denominator of the first one, and x minus 2, y plus 1 in the denominator of the second one. This first one already has the x minus 2. It does not have the y plus 1, so it needs it in both top and bottom. Carry the plus. The second one has a 4. It has the y plus 1. It does not have the x minus 2 piece. Let us distribute across the tops here, and then we can combine into a single fraction. So multiplying across the top, I've got 8y plus 8 is over this x minus 2y plus 1. And the second fraction, if I multiply the 4 in, that's 4x minus 8 all over x minus 2y plus 1. And now I can combine these into a single fraction because they now have a like denominator. So adding across 8y, if I add 8 to negative 8, those are gone. And then so plus 4x is all over x minus 2, y plus 1. Now, if the homework says to make sure you redistribute everything back out, We can do that here. X times y is xy. X times 1 is x. Negative 2 times y is negative 2y. And negative 2 times 1 is negative 2. So that would be the denominator with 8y plus 4x on top. Last problem, we have 7 over x squared plus 2x minus 15 minus the fraction 3 over x plus 5. So let's see if we can factor this one here. We want to multiply to negative 15 and add to 2. That's going to be 5 and negative 3 because 5 minus 3 is 2. And 5 times negative 3 is 15. So we have 7 over x plus 5, x minus 3. I'm going to make this plus negative 3 over x plus 5, but we also need to get that x minus 3 here, so I'm going to put that on bottom and on top. Now I can distribute that out. So that makes negative 3x plus 9 is over x minus 5, x minus 3. And now we're going to combine into a single fraction. So denominator is x plus 5, x minus 3. So let's see, 7 plus the like term over here we can add is 9. So 16 and then minus 3x. That piece does not combine with anything. And if we want, we can rewrite this denominator back in its written form, which was back here. X squared plus 2x minus 15. This is the end of this section. You can do your homework, and the next thing that will be up is the quiz over this review chapter.